cos squared theta minus sine squared theta. So you can also write this as cos 2 theta equals cos 2 theta minus 1 minus cos 2 theta or squared theta. And you can rewrite this as 2 cos squared theta minus 1. So you have to know, you can see, if this is 2 theta, this is going to be theta. So it's divided exactly by 2, right? So if you look carefully, I can also write cos 6 theta equals 2 cos squared 3 theta minus 1. Same exact thing, just divided by 2. So if it's 2 theta here, it's going to be theta here. If it's 6 theta here, it's going to be 3 theta here. That's how the rule goes. I can show how I can prove this later. If anyone has doubts regarding this, just drop a comment out. I'll drop another video regarding on that. So we can use that. So you can write also, you can rewrite this again. So cos 6 theta equals 2 cos squared 3 theta minus 1. Now let's subject this, because we need to find the integration of cos squared 3 theta. So you can write cos 6 theta plus 1 divided by 2 equals cos squared 3 theta. Now you got to integrate this. So when integrating this, you can write half plus half cos 6 theta dot theta. When integrating half, it's half theta plus half into the same way we did for cos 3 theta. It's going to be half into 1 over 6 sine 6 theta. This will give you half theta plus 1 over 12 sine 6 theta. Let's put this back into our previous one. So we got theta plus 2 over 3 sine 3 theta plus half theta plus 1 over 12 sine 6 theta. Yep, so you can rewrite this again as 3 over 2 theta, I'm just adding these two together, plus 2 over 3 sine 3 theta plus 1 over 12 sine 6 theta. Now we integrated it. Now let's put in our integrals, pi over 3 and pi over 12. The whole thing into half. Well, we could multiply it by half straight away, so you can put 3 over 4 theta plus 1 over 3 sine 3 theta plus 1 over 24 sine 6 theta. Let me just go through again whether I did everything properly. Yep. Yep. Okay, now we sub in the intervals. So let's put 3 over 4 into pi over 3 plus 1 over 3 sine 3 into pi over 3 plus 1 over 24 sine 6 into pi over 3. this subtracted by the second interval. So 3 over 4 into pi over 12 plus 1 over 3 sine 3 into pi over 12 plus 1 over 24 sine 6 into pi over 12. So you gotta use your calculator for this one. So for this we can straight away write pi over 4. And for the others you can write 1 over 3 sine 3 into pi over 3. That's 0. 1 over 24 sine 6 into pi over 3. That's 0 again. This subtracted by, so you can rewrite this. 3 divided by 12 is 4. Pi over 16. 1 over 3 sine 3 into pi over 12. That's root 2 over 6. 1 over 24 sine 6 into pi over 12 is 1 over 24. So this is going to give you, so you can write pi over 4 subtracted by pi over 16 subtracted by pi square root 2 over 6 subtracted by 1 over 24. We just write a decimal answer for this one. Pi over 4 minus 16 minus square root 2 over 6 times 1 over 24. This gives you 0.3116. I just wrote a whole bunch of decimal places so you can get the even more accurate value. So now we found the area of the shaded region that I mapped. That's done. And now let's find the area of the triangle. So the area of the triangle is half into the radius was 2 plus square root 2 over 2 squared into sine pi over 12. This is the equation to find the area of any triangle. Oh, yep, for any triangle. So the equation I used was half into r squared into sine theta. This was the equation. So let's say it was an irregular triangle with 3 different shapes, 3 different sides of different lengths. So it won't change anything. So let's say this was 3, let's say this was 5. And this angle was 30 or something. So you can just write half into 5 into 3 into sine 30. You can do it like that. Okay. So then I'm just going to put this in the calculator and get the area for the triangle. Half into 2 plus square root 2 over 2 squared into sine pi over 12. This is going to give you 0.377. Okay, now we got the area of, let's call this, A. No, I'll call this X. I'll call this Y. Okay, the area of X was 0.31168. Area of, I wrote off twice. Area of X, area of Y is 0.377. Now we're going to find the area of the shaded region. So we can add x and y. So if you add x and y, you get 0.3168 plus 0.377, 0.68868. We leave it like that. Now we found the area of this whole section. We found the area of this whole section. Now to find the area of the shaded region, to find this area, you need to find the area of the whole thing, the whole curve, the total area of the whole curve, and subtract it with this area to get the shaded region. So let's find the area of the whole curve. So we previously found the integration for the whole curve. You can use this straight away. We don't have to do it again. So you can use 3/4 theta plus 1/3 sine 3 theta plus 1/24 sine 6 theta. All we have to do is just change the intervals. So the intervals for this, for the whole curve, it's going to be from the initial line to the angle we found earlier. So initial line, it's 0. Angle for the initial line is 0. And the previous angle we found here was pi/3, right? When r equals 0. It's going to be 0, 0 to pi/3. So when I substituted pi/3, I just got pi/4, right? So I can put in pi/4, subtract by, if you're putting 0 to everything, it will just end up as 0. So pi/4 is the area of the whole curve, which gives you 0.785398. Okay, now all you have to do is just subtract this area with this to find the shaded region. So shaded region is 0.785398 subtracted by 0.68868. So 0.785398 subtracted by 0.68868. This will give you 0.0967. Yeah, it can give you an answer like that. Units squared. So this is your answer. So let me just go to the answers. 8C exercise 8C. Yep. You can see it's 0.0966. Yep, it's just small decimal place. Not a decimal place, it's just this number that's different. But that doesn't matter, because you got the answer. So that's everything under this question. I hope you understood. If you have any doubts, you can just drop it in the comments. And any questions you guys have, just tell me. I can definitely help you out with them. Yep. Thank you so much. Have a great day.